Hello, my name is Olivier Han. I'm a senior technical consultant working for HPE Aruba Networking. I'm more especially working in the proof of concept team and here assisting the technical marketing engineerings to introduce new features like this one, which coming with a 10.13 release and which whose name is VRF export route map. Regarding the agenda for the session today, it's usual agenda, so we'll cover an overview of the features, check some use case where these features would apply, look a little bit more into details and caveats coming with the features, how to configure it, what's the best practice, a couple of troubleshooting, and at the end, a demo to see the feature in action. So let's start with some acronyms that are going to be used during this session. IVRL, so it stands for Inter-VRF Route Linking. For IVRL, we have the DIVRL, which is a dynamic based on BGP, or SIVRL, which is a static based on static routes. Then we might be familiar with the routing table, the FIB, which is a route installed in the ASIC, forwarding information base, and the WIP, which is a representation of the tables used to select the next stop. And we will introduce the concept of RD, route distinguisher, and RT, route target. Okay, so first stance, what is inter-VRF route linking? So it's first, it's still when you have multiple virtual routing forwarding instance. So you want to segment your routing table into multiple compartments. So it's very useful when you have different type of business unit customers. I do not need that you want to isolate from each others. So in this example, we have a green tenant, red tenant, and let's say an internet, which has might be a kind of shared services. When we speak about leaking, it means that one resources in one tenant, let's say in the green tenant, needs to access a resources in another tenant. It can be internet or the red tenant. So the connectivity is required, even if the first goal for VRF was to segment it, but we may guess about some exception. So how does it work? More from a technical standpoint. So it's installation of prefixes from what we call a egress VRF. So it is a VRF, the source VRF leaking the route into the ingress VRF, which is a VRF receiving the route. So basically, we install the prefix from a routing table in a VRF to another routing table into the ingress VRF. And this is a local process, so sometimes it can be a bit confusing if we can influence the leaking about neighbors, but not in this leaking process, which is purely local. So here we're manipulating the routing table of the local device. Then there is some other possibilities, yes, to advertise these leaked routes to neighbors, to peers, that we'll see later on. Is it fully new features for AOS-CX? So not really. So dynamic IVRL, I've been already covered in the 10.9 TOI, so I recommend you to have a look. Yes, the exact name is DIVRL with default VRF TOI presentation here. And so there was a couple of features that have been added between 10.7 and 10.9. We have the static route, dynamic, IVRL, and default VRF was considered as any other tenant VRF where we can configure RD for this default VRF. 10.12 1000. So not only the first release in 10.12, but in 10.12 that 1000 what came. So it came with a VRF export route map. So it's this the subject of this current presentation to cover this VRF export route map. And in 10.13, there is another evolution coming, which is how we can add route target in this export route map. A quick recap regarding static IVRL. So just to make sure that this is well understood. So it's a first way to do route leaking. It's more convenient when we have very few routes to leak. So let's say you have a default route for the internet and you want to inject into your customer tenant. This can be useful. If we want to make something more scalable, more dynamic, it will be the dynamic IVRL. So how does it work? So let's guess that we have a switch with two VRF, red and blue. We want to provide connectivity from a host A, which belongs to the VRF red, to a host B, which is behind a VRF blue. So even not in a VRF, let's say, but behind a VRF blue. So by default, yes, this host A and host B have no connectivity at all. So on the switch, we will configure a route, so a static route. So first to go from host A to host B. So for the destination subnet, which is 192.168.30.0/24, which is here, you always need to specify a AOS, so outgoing interface, which is this interface of the switch, 1110, and can be also a good practice to add a next hop. So let's guess you can have this host B is connected to via different paths. So we could have several IP-LOS, so we could do ACMP, so equal call multipass for these routes. And very important to specify the VRF wet, which is the source VRF here. For the return traffic now, to go from host B to host A, so we need on the switch to configure a static route for the 192.168.12. So here's just a bit different. So it's that this network is directly connected. So we'll say it is egressing the interface 1120, and this information is valid for the source VRF blue. So yeah, I just wanted to highlight a little bit this command, which can be sometimes a bit confusing regarding the VRF, which one to specify which interface. So yeah, you may have this reference. Now let's speak about dynamic IVRL, which is more usable, yes, in a production network, in a more scaled network, let's say. For these concepts I am introducing, so we'll see. Yeah, let's say the life of the route advertisement from 10.1.00/24 coming from a wide VRF, and we want to advertise these routes, which is, let's say, a wed prefix to a VRF blue to an OSPF peer in the VRF blue. So first, we'll configure your router OSPF in the VRF. And yes, let's say you receive, so we configure this interface for this OSPF 10, and we will receive this LSA, so this link state update, and you will install, so the switch will install these routes in the database for the OSPF 10. Since, let's say, this route is only known by this protocol, so yeah, it will be installed in the VRF, in the wait forwarding information base. Now, what we need to do in your VRF wait, so we have the distinguishers, and in the address family, you will also configure a route target. So we'll see the concept of RD and RT just after. And this command will add the route target to the prefix to a table. So you see layer 3 L3 VPN. So it's a table which is maintained inside the switch, especially to deal with this VPN v4, so with the MPBGP information, and is used for this leaking upward from one VRF to another VRF. Another point which is really important here is the redistribution of the protocol of OSPF 10. So this is the number of the process, OSPF process that has received this prefix. And we need to redistribute this process into BGP. So when you do that, the prefix is sent to this layer 3 VPN table for the VRF wait. Now, if on the VRF blue, which is on the route part, in the VRF configuration, we have a route target in port 100 semicolon 1, which is exactly the same value as what is exported by the wait. This prefix will be sent, will be copied in the L3 VPN tables for the VRF blue. What will happen is that this prefix is exported in the forwarding information base for the VRF blue. And at this time, so it's going to change in the futures, the route target, so the route target which was 101, semicolon 1, the prefix is advertised to the BGP, so it's installed to the BGP address family, so in the MPBGP table in the VRF blue. Now, if we want the routes to be in OSPF, so here we have an OSPF 20 process for the VRF blue, we need to import the BGP route. So let's say yes, the prefix was in the BGP address family. We redistribute this route, and then this route can be advertised to the OSPF peer in the VRF blue. So this is how we set previously. So this leaking process is purely local, so it's based on this L3 VPN tables. But then you can redistribute also, you can advertise this leaked routes to also any other peer using routing protocols. Maybe some recap regarding route distinguisher and route target, because these are two concepts that are usually mixed and not very well known even. So first stance, we think that we know what it is. So just purely in terms of packets. So the route distinguishers is 8 bytes value. So we have 3 different types to represent this value. The type ID will represent 2 bytes, and 6 bytes remain for the value itself. We can be a mix of AS numbers and a specific value, so 4 bytes for this value, 2 bytes for the AS numbers. We can use also extended AS numbers, we're using 4 bytes, which remains 2 bytes for the exact value, and or use IP address, or use an IP address format, semicolon, 2 bytes value. RD, you just need to consider is a number. It's just a numbers that will be used to identify these routes. Let's say on a service provider network using MPBGP, so usually in MPLS network, in provider edge devices, we are building MPBGP peering, so VPN v4, and this is a way to distinguish prefix from one VRF to another VRF. But yeah, it's just a number except of providing routing information for a 4 bytes IPv4, and it will be a 12 bytes VPN IPv4 address. The same for IPv6. So this how distinguisher is transported in the MPBGP advertisement to make it unique. And the interest, the benefits, is that you can reuse the same IP address, yes, between different VRF because the RD will make the value different. So even for the 10.0.0/24, because of the RD prepending is different from this one, is two different route information, two different VPN IPv4 address. But, and it's usually what is confusing with route distinguishers, it's not indicated at all where the route is being redistributed. So in which VRF. So just to make it unique, but not controlling the propagation, the installation of the prefix into the routing table, into the VRF routing table. When we are doing a little bit L2 VPN, you can see in the configuration we have this auto keywords for RD, which is convenient if we don't want to specify it manually on each devices. And what is going to do the auto on CX switches? It will fill the RD with a VTEP IP address, so which is usually the loopback one, and the VLAN ID. It is recommended, yes, on the networks to use different RD per VRF for sure, and on each logical VTEP. So let's say we have a VSX pair for a VTEP. We will use here the same route distinguisher. So it's useful to differentiate RD per VRF also for troubleshooting. So to isolate quickly where the route is, where this prefix is coming from. Now, what target? So the what target is more than a value, is an attribute. So it's a BGP extended community attributes. So where the RD is not, it's appending to the IP address, so it's building a new value, a new prefix which is advertised. Here the RT is different, is really an attribute which is added to the prefix, to the what we call the BGP NLRI, to the BGP advertisement, and so it's optional. So it doesn't need to be appended, to be added to the prefix, but it's transitive. So it can be sent to others. So usually you need to specify in the BGP configuration a send extended communities to the BGP peer, so the BGP peer can receive this RT information. This one, route target, is really used to control the import and export of the route within the different VRF. One or more route target can be appending to a prefix. Yeah, so this can be the case. If you want, if you deal with L2 VPN and multi-fabrics, so if you deal with, you need to stretch VRF into different fabrics. So on the borders, you will be able to set this extended community will be for you a tag for this specific VRF. So on the others fabric, the device, the VTEP, will be able to recognize this prefix that I need to import this prefix into the VRF routing table. And on the reverse, also, we can use a local scope to avoid these words to be propagated or to be installed later on other VTEP in other fabrics. So it's really a way to control how these routes are installed in the different devices. Now, how will you configure this route target information? Basically, we have two main different ways to make this configuration. I took this example of 3 VRF. So a customer A has a green port, a customer B has a white port, and a shared, which is a blue VRF. So let's say customer A and customer B need to advertise the routes to a VRF shared. So to get some connectivity to resources in the VRF shared. So we identify customer A with a semicolon 1, customer B with semicolon 2, and the VRF shared will import all the different route target from customer A and customer B. So in this context, the route, the prefix exported from the customer A have only one route target. Our customer B, they have only one route target. This is appropriate. This is maybe the easiest configuration when you have a limited number of VRF. So your VRF shared configuration is not is not too much complex. The option 2 is to introduce an additional route target. So here to simplify the configuration of the VRF shared. So here we will introduce a new route target, because we can say we can add as many route targets on a prefix. So here now from the VRF customer A, we'll have two targets, so semicolon 1 and semicolon 1, 2, 3. And we can configure the same one as an export from the customer B. So an important point in the route leaking is that there is no transitivity. So a route can be leaked from one VRF to another VRF, but not cascaded to a third VRF. So no risk of loops, I would say, in this case. So here we will add this import. So we have a very simple, easy configuration on the VRF shared, which is maybe the most important, because let's guess we had a third, a fourth, a fifth VRF. So we just export this 1, 2, 3 in all this new VRF, and the shared VRF configuration is not going to change. So this way to configure the import and export is more applicable for higher numbers of VRF, more complex, let's say, topologies. And also another concept that we are going to see later on is a selective route target export, selective IVRF. So in this context, we'll expect the use case later on, but might be that we don't want to leak exactly the same prefixes to all ingress VRF. So let's say from the customer A green VRF is the egress VRF leaking the routes. It will leak routes to the VRF shared, the blue one, and the VRF customer B, the red one. And for any reasons, the 10/8 will be exported to the VRF shared, but the 192.168.0.0/16 will be exported only to the customer B. So we have different ways here. We have more flexibilities. So some prefixes are linked to a selected number, so selected VRF, and not the same one. So now let's look a little bit at the use case for these features. So let's take an example. A big campus, so it can be also a data centers with different VRF here. So the purple one will be the shared VRF. We can imagine we have a DHCP server, with the option 82, which is able to provide information about the VRF. And the DNS. So for DNS, we are usually using multiple domain name to separate also the VRF information. But yeah, from an operational perspective, we want to have only one DHCP server, one DNS servers for all the different VRF, and usually also one management and monitoring system for the web servers. In the VRF, also we can have some servers that may have the same IP address. So yeah, there is another option which is address translation, so using that. But if we don't want to provide more complexity, or you want really to have a best control on the words that needs to be linked to the shared VRF. So there's the first question we need to wonder, we need to ask. So do we really need to link all the word table, all the yellow, the VRF yellow and the VRF blue of routing table to this shared routing table? Most of the case, no. It's better to have a full control for all the different scenarios that I just highlighted. Also, if never we don't add any control, is there an easy solution, an easy way to restrict the traffic, to restrict the connectivity between different resources, between different servers? And the answer is no, yeah, because if we want to control this traffic flow, you'll need to apply access control list. And there is no central way, there is no global point, it's not applicable to a VRF. Like a layer 2 access list can be applied to a VLAN, so this is possible, but we don't have the concept of a layer 3 access list which is applied to a VRF. So we need to apply access control list on the individual SVI, or so the switch virtual interface, or the routing port. Yeah. So it makes the solution more complex. So the best way is not to leak these routes. If the connectivity is not needed, it's better than leaking all the routes and trying to apply some access control list. Another use case is a selective IVRL. So here we usually need to think about data centers and customer. We have some co-location, co-location services from the service providers. So usually we'll have different here RDs. That's why I represented dark green and a light green for the co-location with different RDs. So here we need to exchange all the routes. So it's like if it's one single network, so under the same administrative control. So we want to exchange all the routes which are depicted here. So now we're adding services. So this data centers is also providing some shared services. With 192.168. What happens is that in the services, we don't want to receive the 172.16. This one can be used by different customers, and there is a rules imposed by the service providers not to leak this, not to use this 172.16 address in the shared services. So here, the way to do that is using a selective IVRL. So 172.16 to exchange with this customer A colo VRF, but for the services to avoid, so to withdraw the leak of this prefix into these services. So this is one application of the selective IVL. Regarding the support of these features, so basically, as long as the VRF is supported on the switch, it's supported on any product in the portfolio, because on the 6200 is supporting only the default VRF and management VRF. So definitely there is no linking between these two VRF. Regarding details of the features, so we'll see the configuration later on, but regarding this export route map, VRF export route map, it's supporting in the IPv4 address family and IPv6 address family. For layer 2 VPN, we will see, so you don't find a command in the layer 2 VPN, but we need to go through this IPv4 and IPv6 address family and using import and export. Also with the layer 2 VPN address family, we can control the leaking of routes exchange through L2 VPN as well. So BGP VPN. The export route map in terms of matching command support only IP address prefix list. In terms of set action, we can set a metric, so a multi-exit discriminator made in BGP, and we can add one or several route targets. So we can add a list of route targets. So the route target configured by the route map are added to the export route target. So even so, in this first release, we don't have the additive keywords. You need to be cautious. It's not a replace. It's not an override. So let's guess in the BGP, you receive the prefix is received with an existing route target. If you set a route target from the route map, it will just be added to the initial receive route target, but not replacing it. The continue keyword, in the default behaviors of a route map is on the first match. The route map will just stop to be processed. So if the sequence 10 is matching the condition, you will not go to the sequence. So the further sequence can be the sequence 20. So you can use a continue keyword to oblige the system, to oblige the switch as to evaluate the further conditions. So here we can use this continue, but only if the set action in the further sequence will be a matrix. So, it's not possible yet today to add to set route target in different sequences, in different I would call cascaded sequences. Now, if a route has multiple next stop, all the next stop, so all the ECMP routes will be also leaked to the ingress VRF. Regarding VRF export route map and the redistribute route map at the BGP process level, they can coexist. It's a bit more complex, so I will explain in the further slide how it really works. If you modify the prefix list to modify the prefix which needs to be leaked, you want to remove or add a new one, it is taken into account immediately in the ingress VRF route table. So don't need to unapply and reapply the route map, fortunately. What what happens if you configure? So if we type a command and the route map is not already configured. So we took the choice from an implementation that we want to support it because in terms of CLI orders, so this command will happen before the route map configuration. So using different ways to configure the system, it can be useful. So if that happens, so the route map is, or you do a typo, the route map does not exist, on the system, if there was a previous route map which was existing, it will continue to apply this route map. If there was no route map before, as soon as the route map is created and it's applied as a VRF export route map, then the control so will be applied. We discovered a fix an issue also during some testing that is being fixed in 10.13.1000 is that so as you know there is different ways to import route into BGP. Most common is using a redistribute command, so redistributing from routing protocol to BGP. Another way is to apply a network command if you have a route in your route information base. So if the route is known in the route information base and you apply this network command, it will be imported into the BGP tables. But for this route, they will not be controlled by the route map. So be careful until 10.13.1000. Import route map. So now we are speaking a lot about AOS route map, who target export route map, but what about import? So it's not planned as of today. We can evaluate with a use case and based on the fact that we can set the route target individually for the different prefixes with a selective IVRL. We can control into which VRF the routes, the prefix are being imported. So finally, we don't need this additional import route map features to get a control about the installation of route. Selective IVRL. So if we set the route target in the route map, we need to have the additive keyword supported. So this is something I just mentioned before if we want to add route target in different sequences. Now let's speak about coexistence of redistribute route map and export map. So I guess we have different information here for different prefixes coming from BGP 10.101 and coming from different other routing protocol, not only IGP, but yes, all, let's say, protocol except BGP. So it can be a loopback, it can be a connected network, it can be a static route, it can be an OSPF. So if we apply a route map to a BGP peers to deny the 10.103 in this case, and we apply also a route map in the redistribution for, let's say it's OSPF route, so redistribute OSPF route map to deny the 10.10.3. So in our BGP table, we don't see the 10.103 as expected, and we don't see the 10.10.3. In the BGP table, so here it's coming the BGP route will install in the FIB. So, but since it's not there, so we don't see the 10.103. but here the OSPF 10.10.3 is coming from OSPF, will install directly in the FIB. So far, so good. Now we go to the leaking process using the L3 VPN table, as explained before, and we don't apply any export word map. So we get an exact copy of the BGP table into the forwarding information base of the VRF wet. Okay, so 10.10.3 was not imported into BGP, so is not exported, I would say, in the wet FIB. Now, if we have a VRF export map, and in this VRF export map, we permit the 10.103, we permit the 10.10.3, and you see we don't permit also the 10.101 and the 10.10.1. So what will happen in this case, in the FIB of the wet, we will have the, so it's overwrite, I would say, here's what is coming from the BGP table. So we'll have the 10.102. We'll have the 10.10.2, the 10.10.3, which was not in the BGP table, but we don't have the 10.103 because the 10.103 was discarded, was dropped even before coming to the BGP web. So what is important here and what can be maybe not obvious the first time is that the 10.10.3, which is not part of the BGP table, because in the redistribution from OSPF to BGP, we deny this prefix, is still leaked, is still part of the wet FIB. Yeah. And so it gives us much more flexibility, I would say, because it can happen that you want to forbid a prefix to be installed in the BGP table, because if it's not there, also definitely it's not going to be in the BGP WIP of the VRF wet. Okay, so 2 points which are very important. First one is to get a WART coming from one of these routing protocol airs. You need to redistribute this protocol into BGP. So this is the first point. The second point is that even if the prefix is not allowed if you apply the route map, which is optional in this redistribution, you can still leak the route if the VRF export route map explicitly allow this prefix. Now let's have a look at the configuration. So can be some recap for some part of the configuration. First, the VRF configuration. How is it configured? So we'll go to the VRF context. We configure a route distinguisher. So we define the different IPv4 and IPv6 unicast address family. And here you will defines your root target with export and import. And for IPv4 and IPv6, you need a different value. Okay. Same for VRF wet. So, okay, here we want to leak green routes into the VRF wet. So we'll import the value, which is exported by the green one. The same for IPv6 address family. So far, so good. Now the multi-protocol BGP configuration. As I said, you need to redistribute the protocol into the BGP, into MPBGP here. Now you need to configure a prefix list, or what we want to leak as a IPv4 prefix. We can, as I said, set metric value, and the same for IPv6. So for the prefix, so yes, command IP prefix list for IPv4, IPv6 prefix list, and matching IP and IPv6 in both cases. And then at the end, you apply this word map. So this is really the new command in the address family IPv4 and IPv6. The command is word target export word map. And then the name of the word map, as I explained before, that does not need to exist, but will be applied if it exists. Now regarding the option 1 for the architectures of word target. So in the option 1, so we have one word target which identify each egress VRF, so 10, 20, 30. And if we want to redistribute these words to all VRF, or to both VRF, yeah, we are distributing, we are leaking words from the VRF green to orange and red. So we will set both community using this command with a space in between. For the prefix that we want to leak only to the orange, it will be this specific VRF which match with the import here. And this going to red, so the 30 match with the import for the VRF red. So here, this is example, we can use this continue command because the last sequence is a set metric. The limitation of this solution is each time you will add a new VRF, so this sequence 30, and this is something I don't like so much, to modify a route map sequence, so it can if you make any mistake, so it can break everything. So, and another maybe more elegant ways to build the route map is not yet supported, which could be to do in the first sequence to use a prefix list to identify all the prefix, even the common prefix with the other ingress VRF, all the prefix in the prefix list to set this community. And if it's matching also the second one, so we'll add 30. So we'll add 20 and 30 in both sequences. So this one will come a bit later, so with the additive keywords. So the option 2, which can be a bit more elegant and a bit more scalable, here you will define a word target value, which will represent as a leaking for importing into orange and red. So here my 100 will identify ingress VRF orange and red, and they have also the unique VRF number, which is unique AT number, sorry, which is 20 and 30. And here in terms of word map, the sequence 30 is much simpler because we had only one community. You had another VRF, so we'll add another sequence to set the community of this unique VRF. So let's say it's VRF blue with our target 40, so we'll add a new one. But for all the prefixes that needs to be linked to all the VRF, orange, red, and blue, we'll still stick with this value 100. So I think from the beginning, when you are building your configuration, it's better to define if we go to option 1 or option 2 based on the complexity and the number of VRFs that you may have, or if you can expect configuration change in the futures, might be better to go to this option 2. What happened to L2 VPN, so to BGP eVPN? let's say here that we have borders and so running green and red VRF, and we want to to leak some specific green prefixes into the red VRF, but not all of them. So yeah, as you said, if we look at the EVPN address family, if you look at it, there is no export word map keyword. So here, this 11,001, yes, you need to import and export this route target in the address family IPv4 and maybe IPv6 as well, and to export, so to apply this export route map on the address family. On the VRF red, then you will import this route target that has been set in this IPv4 address family, and an access VTEP, so which is receiving the different VRF words through the EVPN address family, will be able to receive the green prefixes into the red VRF at this stage. So this is this way we have to go through IPv4 or IPv6 address family, but not the route map directly on the EVPN address family is not applicable. If we now compare AOS-CX implementation with different vendors or other product type, so on AOS-S, as you know, we are not supporting the VRF, so it does not make sense. H3C HPE Comware, yes, we have a command also, which is the export word policy. Cisco iOS, also the feature is available through the command export IPv4 map, except that here the implementation is a bit different. Is that if you apply this word map, it's not going it's going to replace what has been configured in the VRF at the VRF level as the export word target. There is also an import map in Cisco, but here it's more like the OSPF distribute list. So the words are still imported, are still received, but just the word which kind of are in the BGP table, but not imported into the FIP, into the forwarding information base. What about the best practice with this feature? So first, let's say when you configure it, let's keep the orders. So first configure prefix list, word map, and then apply the word map to the VRF. No duplicate prefix list across the egress VRF. So if you leak the same prefix to an ingress VRF, the problem is that this ingress VRF will install these different words into its routing table, which will make it completely unusable because it's not possible to do an ECMP between different VRF. Also, until 13.1000 do not use a network command. And as much as possible, except if it is really on purpose, you don't want to redistribute a specific route into the BGP tables, try not to get conflicting roles between the redistribute route map and the export route map to make it more simple also for the operation and the maintenance. Now in terms of troubleshooting, so what do we have as a command? We have the show BGP info VRF. We will provide some information about the configuration of the VRF with the world target list, which has imported, exported, and the redistribution also of the protocol into the BGP. And show BGP VRF will display the BGP tables entry for the specific VRF. And here in the extended communities, you'll be able to see the word target. So yeah, it can be several values. So also the same for IPv6. And maybe the most useful command is a show IP route VRF in the ingress VRF to see if the route has been installed. And we can see here we have ECMP, so we have two next stop, whereas egress VRF is a green one. Now let's proceed at a quick demo for this feature. So I have prepared basically two different use cases. So here I have Nixia, which is sending a number of routes, so OSPF and BGP, in the first scenario to a green VRF and to a red VRF. And I have a shared, or let's call it VRF services, where I just want only a subset of routes. So as you can see, it's a green VRF. I have some 192.168 subnets, and it's exactly the same in the green and the red. So you'll see what happens by default. And we will apply a route map to deny this 192.168. So now let's switch to the CLI. We are connected to 6300s running the latest 10.3, 10.13.5 release. And so if you remember, so we have received a couple of routes from Ixia in the green and red VRF. So we just do a show IP routes VRF. Let's start by green. And you see I receive some 10.10.0. So this one I want to link to my services VRF. So this one I receive by OSPF. I receive from BGP, so 10.10.100. And I have also a couple of 192.168 address. So it's advertised from two peers, so two next up. So that's why I have two lines for each prefix, so which is ECMP. Now, if I look at the red VRF, so I have 10.20, so this is the difference regarding the 10 IP address, and the same 192.168 OSPF and BGP. If I look at the configuration of the VRF, so for the green, you see I'm exporting semicolon 10. For the red, I'm exporting semicolon 20. And in the services, no way to export here, but just importing 10 and 20. So by default, so it's before the concept of this export route map, expert route target route map, I will have all the routes in the VRF services. You can look at it. So 1010 is routes coming from the VRF green. You have also in the column VRF egress. You can see that. Then VRF red, we have all the 1020 from the egress VRF red. And 192.168. So what is interesting here, as I said, so we have the two ECMP next up for the green. Here, so just don't pay attention to this one, should be wet, so this one is the next stop for the wet. So yeah, so because this prefix is common to both egress VRF is leaked. So as I said, this finally all the resources into this subnet is not usable because the switch will do an ECMP between based on packets onto the different ECMP hosts. And it's not the best practice anyways to, and this is why these features also is coming, is to get a better control on the leaking of the words. So I have built a prefix list, which is a deny 192, just with two entries. So I deny 192.168/16 with all the prefix mask above 16, because here it's /24 prefix length mask, as you could see, and I permit all the rest. So this one I need to build a word map, so I call the same name, show word map deny 192. I just have 1 second. So I redistributing, leaking for the prefix list deny 192. So we need to apply these word maps to both egress VRF, which are the red and the green. So let's configure it. So for the VRF green, so let's do it only for IPv4 in this demo, and we'll have a root target export command word map, and we say deny 192. I will do the same for the red, which is the other egress VRF root target export, so we can apply the same. Now let's look at our VRF services. It should remove all the 192 prefixes. As you can see, we have only 32 prefixes now, and none of the 192. We have the 10.10 with the two next stop, which is coming from the green VRF, and we have the 1020 from the red VRF. This is the end of the first demo. Okay, so now let's consider the second demonstration, which will illustrate the selective inter-VRF word leaking. So here we will only consider as egress VRF's green VRF, which is receiving OSPF and BGP prefixes and installing into the FIB, and for any reason. So we have two ingress VRF, orange here, orange, and the blue one. And let's say I keep the last subnet here we see, so which is a 1010.7. This one will be common to the both ingress VRF, or 1010.107, which is received by BGP. And for the orange, let's say it's a kind of co-location, so we can advertise also the 192.168 here. And the blue one is more restricted and will receive also, for the example, others 10 network, but 1010 and 1010.100, which is the first networks to remember in the list of subnets that is received by the green one. Okay, so now let's see how we can influence, how we can configure this behavior. Think back on the 6300 used for this transfer of information. So the root advertisement from Ixia didn't change, so let's have a quick look at the routing table for the green VRF, where I receive the 1010.00, 1010.100 from BGP Great and the 192.168. So here we want to to link different prefix lists into different ingress VRF. So we will play with the orange and blue one. So we have selected the option 2, which is more scalable, where I am introducing, let's say, a value of 1000, which in my mind is a value that can be used for all the ingress VRF in the future. Since I had a purple VRF, I will add also this import. And I don't need to change, my last sequence to export to leak all these the words for all the VRF. And for the rest, yes, we have an ID which is identified. For the blue is 40, and for the orange is 30. Okay, which is exporting and importing into this VRF. Here, just keep in mind also we need one value, even if it is a dummy value, when we set a WAD target in the WAD map. So if we don't apply any WAD target export, the WAD map will not be able to add a WAD target, because it's just not a replacement, it's an additive one. Okay, so let's look at some prefix list that I have built before. So I will say I have a prefix is what I want to leak to the orange VRF, so 192.168, yes. So this one are unique leaking to orange. From green, what I want to leak to the blue VRF, so the 10.10.00 and 10.10.100.0, and what I want now to leak to all, which are the 10.10.7, 10.10.107, which will be common to all, with RT1000. So here, if we see the route map, so I have a route map, export green. We can see I have basically 3 sequences here. If I'm matching the prefix list linked to orange, I set this word target 13, which was the identifier 13 for the orange. For the blue, it's 14. So we'll see that. If I'm matching the prefix list linked to blue, I set external community RT 40, and 1000 is for all. So let's verify that in my VRF blue and orange, I don't have any route. So in blue, I don't have even one interface attached to this VRF. In orange, I have one interface, the loopback. So let's apply. So because why there is no route? Because I don't have any import 10 in this VRF. So what I export from the green perspective is 65,001 semicolon 10, and I don't have this import value in both orange and blue. So this is expected. We don't have any words from the green VRF. So now I'm going to apply the word map, which is doing 2 things, which is doing a control and which is doing a set word target. Okay, and this one is in 1013, whereas the export to word map is in 1012,000 release. And then I will word target export word map, green export, export minus green. Now, let's look at the different VRF routing table, blue and orange. So you see it's immediate. You see the age of the words 10 seconds ago. So I have the 10.10.0. It was the first subnet from OSPF and from BGP redistribution. and the last one which will be common. And if I look at the orange, I should have the 7 and the 192.168, if we remember. Okay, so I have the 7, which is common, and I have the 192.0.0 redistributed from OSPF and 192.100 redistributed, which is coming from the BGP. So this validates through this demo that with these new features, we can first control the leak from one egress VRF to multiple ingress VRF, or from multiple also egress VRF to one ingress VRF in the first demo, and we can also control which prefix is being leaked to which VRF, so a selective selection of the prefix based on the ingress VRF. So here it's really the ID for me of the import word map control. This ending the demo of these features. Of the presentation of the VRF export route map presentation introduction in 10.13 Aruba OS-CX release. I hope you find these features interesting that you can apply in your design when you have multiple tenants and you need to have a better control on the type of routes, so the routes that are leaked from one VRF to another VRF, and even selectively shows which prefixes needs to be egress needs to be linked to the specific VRF. So it gives you a lot of flexibility now into your configuration, into your solution. And yes, and I hope you find it also interesting. And this is the end of the presentation. Thank you and bye-bye.